minute. Go ahead and when you're ready.
All right. So welcome back, everyone, to the hardware management track. The next item on our agenda is a panel discussion of Accelerator and device management. It will be led by Hemal Shah. And Hemal, take it away.
Okay, thanks, Bob. Let me. So I am hardware management co-lead as well as at Broadcom. I run architecture team. In this panel, what I was thinking about as a part of hardware management and server sub-project, as participating in those, I realized there's a lot of collaboration going on, and it'll be good to get perspective of other projects or sub-projects within that. So specifically here for this panel, what I want to talk about is focus on accelerator and device management. And I have invited three key panelists here. Bapi, who is an architect within our team at Broadcom, is also sub-project lead of ODSA, Open Domain Specific Architecture. Then we have Damien, who is hardware engineer at Facebook, as well as he's sub-project lead of OCP, Maz and Nick. And then Whitney, who is also hardware engineer at Facebook, and she's sub-project lead of Open Accelerator Infrastructure. Tiani, who also co-leads that sub-project with Whitney. Unfortunately, she couldn't be here. So we will have three panelists go over their views on this. What I was thinking is, as I mentioned, Maz and Nick, Damien will cover Open Accelerator Infrastructure, Whitney will cover an ODSA Bapi. And to kick off the panel discussion, what I was thinking, let's start with three key questions here, starting with the use cases and requirement, talk about the challenges and where do we see the gaps in the standards. And after we go over each panelist giving their answers to those questions, we can open it up to audience for any Q&A. So that's the structure of this panel. With that, let me hand it to Bapi to begin ODSA. Bapi.
Okay. Morning, everyone. I'm Hemal. Happy to be here on the panel with Whitney and Damien. So in terms of use cases and requirements, I think for at least on the ODSA side, where we're trying to build, so the basic goal of the ODSA is to enable the development of multi-chiplet products where you can mix and match chiplets from multiple vendors into one package. So at the end of the day, the outcome is a single device. So we have the typical management use cases and requirements that you see for a single device on a board. So things along the lines of what's the inventory, who's the vendor, what are the capabilities. The second thing we're kind of interested in is how do we monitor the device as it's in operation. So both sort of the device independent characteristics like heat and counters and state and things like that, and also function specific features like application performance. And the third bucket is operations. So you want to upgrade the firmware, you want to recycle the device. So these are sort of three broad buckets in which we see that a device has to be managed. And the group itself has given some thought to this, and we can go into those thoughts as we go into the panel. So that's where. So I think to sum it up, essentially in terms of inventory, monitoring, and operations are the three buckets we see needs in for chiplet-based devices.
Okay. Thanks, Bapi. Let me go next to Damien. Damien, you want to start with your perspective on this, and then we'll go to Whitney.
Yeah. So regarding the management use case on OCP NIC, we are primarily looking into like the NIC sidebar management. So also very similarly, we have three categories. One is the initial identification of the NIC. Second is the runtime management, and third part is the firmware upgrade. So like for the first part, the management use case for identification, in OCP NIC, we kind of standardize the through, we standardize the form factor. That really makes the multi-sourcing NIC easier. So right out of the bat, they are compatible with each other. But as you know, that only means the framework is compatible. Under the hood, it is still a different NIC. That's where the system management comes in and identify what exactly the NIC is. And typically, a system manager, which it is like a BMC on a platform, will come and read the full content and make some decisions. One example is, let's say the system designed for a low power slot, and then BMC can power the NIC into ID mode and check what's the NIC capability and requirement, and then decide to power up the NIC or not, or even do some management, as in, let's say, power up into a lower power mode, like aux mode. We have similar mechanism to thermal. We also define cooling tiers, and cooling, we use the same mechanism to do it. So the second part of management we use is like active monitoring. So one of very simple example that all our NIC cards do is like thermal monitoring. So let's say, for example, the system is using a passive cool heat sink, and then the NIC relies on BMC to provide the sufficient air to cool it from overheating. And all these information are communicated through the management channel. And I will talk more about what is the management channel for OCP NIC in a short moment. And then for another one is like critical error handling and reporting. This is an area we wanted to do. I would say we did not do as good a job as compared to our thermal management. We define very well. Error handling is something area that we still have to work on. And as I mentioned, there's three things. The last thing is the sub-air management for firmware update, especially for some of the newer NICs like the multi-host NIC. Using sideband to do firmware update is actually maybe a better way to go, especially if you have multiple hosts. So all in all, as for our requirement for management, given that OCP NIC define two sideband interface, and one of it is pretty unique to NIC, like the NCSI over IMI, and then another one is more I would say standard across multiple devices, and use case would be like MCTP or SM bus. Both of these have their pros and cons. I will not go through it, but that's why when we first designed and defined the NIC 3.0 spec, both of them exist. So from a NIC 3.0 perspective, a really ideal requirement, hopefully it's not too hard, is the management has to be interface agnostic. One area that we have appreciate Hamel on what your team is doing, the OCP hardware management, and especially you are on the DMTF organization, is porting the TLVM support to NCSI. That is something that from the next step, we appreciate your work on this area.
Thanks, Damien. Thanks for that introduction. Let's go to Whitney. Whitney?
Sure. Yeah, I can talk a little bit about the OEM. The OEM itself, right? We kind of like want to define this common form factor, and then currently we focus on, for example, like with the same OEM form factor, we can have like a one system, and then we can fit in different kind of like OEM. So the management side, some of the use cases, for example, we have the sensor reporting needs, like in the OEM itself, we have the ASIC, we have HBM, and then we have maybe like voltage regulators, right? Those temperature, voltage, power, current, right? Such like sensors we need to report in the management. So second use case for the management is the protection. So ASIC Accelerator is a little bit different because Accelerator, we can do the excursion power. Means even I define, let's say, a 300 watt ASIC there, right? For very short moment, you can like go up to maybe 600 or 500, right? These excursions are important for the to get into the what we call like turbo mode, right? And then to gather the important performance. So with such like features, we need to have the protection just in case like system power is, for example, OCP, right? Overcurrent protection, something like that. For the protection, we need to have this management interface to do something like power capping, power break, right? So for the protection. So this is the second use case. Third use case, we also need to have the error reporting and monitoring features for those devices. Like, for example, memory, we have HBM in the OEM, and then there may be single bit error, double bit error that we need to monitor and then reporting these errors for the management purpose. The fourth use case for the OEM area, I can see is the firmware update. Like Damien just mentioned, like for the NIC related, right, we like to prefer to have the out-of-band to do the firmware update. And then for the OEM Accelerator area, we actually prefer to have the in-band utility to do the firmware update. Since because of the size of the firmware, and then currently we're using SMBus as the management interface that is kind of like too slow for the firmware update. So mostly for the Accelerator case, and then we are using in-band for the firmware update. And so this is the fourth area. The last area is the through, like we need to read the through information. For example, the OEM can be 54-volt based, right? The power can be also 12-volt based. We have some baseboard design can support both, and then we need to read like the information, and then the SerDes link speed, for example, the TDP, right? Those OEM related information we also need to read power when the system is up. Yeah, that's I think that's about 5 areas that we see the use case for the management for.
Okay.
Yeah.
Thanks, Whitney. I think that was great introduction by Whitney, Damien, and Bapi about the use cases. Dirk, let me ask, this is a panel. So do we have any questions from the audience?
I don't see any yet, no.
Okay. So just to, yeah, go ahead, John.
So Hemel, this is John. So
Yes.
I'll ask my questions. So have any of you guys actually been presented or assessed the reference models for both for the accelerator and for the NIC to determine whether it's sufficient for what you guys want to do, you know, external to the system?
Okay, that's a great question,
Because
John.
the reference model right now, I manage the firmware update task force within the reference forum, and we're trying to deal with the 3 modes of firmware update, which is the BMC updates the firmware, the BMC just passes the firmware across to the device, and the device knows how to update the firmware once it's given its image. And the last is some in-band agent is going to update the firmware. So we just basically load the firmware and then notify the operating, and once the operating system gets rebooted, then it knows where to find that firmware image and install the firmware. So I'm just curious, are you guys interested in seeing exactly how that, I would like to see how that exactly would work with your particular components, because we're looking at it at a very general, this should work for everybody type of discussion. And for you guys having specific components that you're worried about, being able to make sure that we've built a model which is sufficiently flexible for both of you guys.
So John, great question. Let's go one by one through the panelists. Whitney, you want to take that question first, then Damien, and then Bapi?
Sure. So like I just mentioned, right, because of the the size of the firmware for accelerators, and then we actually prefer to do the in-band way because of the for example SM bus, the interface is kind of like too slow. So yeah, so if we can have the in-band agent here, I think it will be a great feature, like for accelerator cases.
So in that case, how is the image transferred across? Is it transferred in-band to the agent, or can the agent actually, can the image be transferred out of band, validated, and then the in-band agent can find it once it comes up?
So you mean that by using the out-of-band to transfer the image to in-band?
Right. You use the out-of-band to transfer the image from off-platform onto the platform. And then you boot the OS, and when the OS comes up, the in-band agent says, "Oh, I've got the image. I've been told to go update the component. I can go ahead and do that on the in-band side."
I think that's a great feature. If we have this feature here, I do think this is good.
Okay.
And that can be Redfish based, the interface to the out-of-band, and then in-band to out-of-band communication can be one of these internal facing interface.
Yes. I mean, once we boot, right, once we load the image, bring the image onto the platform, right, and the OS boots, then all we've done is we've placed the image in the right place and told somebody about it, and the in-band agent can use whatever mechanism the system has to upload the firmware.
Yeah, yep. And then I actually have an extra question here. So if the in-band agent got the image and gonna update, right? Do we require anything, like, for example, since we will have a different accelerator supplier, right? Those solution providers, do they also need to support for example, the in-band agent interface with the out-of-band here? Because different accelerator vendor, they may have a different in-band agent, right? We need to define the common interface, maybe.
Yes. So the gap I see is that we can transfer the image and stage all the images out of band. They'll be on the platform. We just need a mechanism for the OS or the app to come down and say, "Where did you put it?" We just want to know where you put it. And then that's the only gap I see. And then each of your installers, right, just needs to understand that interface to say, is there an image for me? And where do I get that image, right?
I see. Okay.
And then it can do whatever it wants to do on the back end to actually get that image down onto the platform.
Okay.
Because we had a lot of people who says we want to stage all updates, right? So all updates get pushed out to the platforms, and then we update the ones we can from BMC. Then we reboot all the systems, so the ones that have to be done in band can be done in band. At the end of that process, then everyone's firmware across all the devices on the platform are have been updated.
I see. Okay.
That was a great question and great answer, Whitney. Let's hear from Damien. Do you want to chime on this? Yeah, go ahead.
So for the NIC, actually we will have we support both, and I will go through the simpler one first. Maybe the out-of-band is more interest from John's perspective. So out-of-band, as Whitney just now mentioned, the SM bus is slow to update firmware. So we have the same thought as well. Out-of-band and firmware update is really slow. That's why when we do the NIC definition, we actually have NCSI and SM bus together in a form factor. So our primary use case of out-of-band firmware updates has been using NCSI, which is a much faster bus. And then we support the PLDM protocol over it. So that gives us the our band firmware update capability. Today, the firmware is still being staged. PLDM is from BMC. You use PLDM to copy over the firmware to the NIC, and mainly because nowadays we in the spec we recommend a secure boot. So the firmware will be staged there, and then the NIC ASIC has capability to check the validity of the firmware. It is a valid signed firmware that we'll use, and then the NIC is actually the one that go and program the firmware into the correct location. And even after that authentication and programming stage, the firmware was not being activated. It only being activated either to a reset or a power cycle. So these are the flow that we have for our band. It seems to me that it is have a good standard behind it. At least the PLDM, OEM, CSI is a good standard over it. And even different NIC vendors seems to use the same mechanism that I think that's pretty good. However, the case is not so similar on the in-band side. And I would say for single host NIC, for example, in-band firmware update is still pretty common. And mainly because in-band is used PCIe, even much faster bus. From in this area, I do see a similar challenge of what we have seen. It is more like different vendors kind of have different tools to do firmware. They're usually proprietary. And John, is this one of the areas that you think the hardware management can work on to have a unified interface? That is actually welcome in my opinion. By only speaking from the NIC group subgroup perspective, still there will be people we need to consult and ask more information from like the NIC vendors themselves, why they want to use the proprietary tool, and what's the limitation if you do it in a open source common tool. So there could be some questions that I might not be able to answer. So I would say, yeah, a unified interface is always welcome, just like the PLDM firmware update we have over the outband. That's my opinion.
Regarding the next, are the firmware images pretty standard on the format of the updated image, or does each vendor have its own proprietary image format for the particular firmware?
I think image format, I am not 100% sure whether they are the same.
So one thing, maybe let me chime in.
I think it's hard to make them has to be the same, right? If you talk about firmware image.
Well, I just want the format to be the same. Okay.
So regarding that, John, one of the thing is with PLDM for firmware update, if you look at it, the firmware package format is standardized and how the images and where the checksums and things are. So that format is there. The piece of image is just treated as a blob of data. And I think there is no, it'll be hard to just trying to standardize everybody's specific image. And I don't think we need to do that as long as we have the common package format, which we do have today.
Okay. Oh, so one thing particular about the NIC and maybe for the other devices is that there's usually multiple NIC on a platform. So the scale at which Redfish is trying to do the firmware update is that you pass an image, a NIC firmware image across the platform, and then either you tell the platform which NICs it needs to update, or you allow the Redfish service to go find all the NICs on the platform and say, I'm going to update these 10 NICs and actually spawn all the tasks to do that. When you guys update NICs on a platform, are they normally across all the NICs, or do you guys have this heterogeneous firmware where one set of NICs might be at a certain firmware level and another set of firmware being at a different level? And does that matter to you?
I can speak a little bit. I think giving the ability to target firmware update on a certain NICs will be beneficial. Even so, if you're talking about, let's say we have a fleet of, let's say 100 servers, and we might even want to do like some of them running at lower firmware, just in case that they could have some characteristic issue with the new firmware that we don't want to bring down the whole system. And for systems that have let's say two NICs in the system, for example, I think it makes sense to update one first and wait for another. Because like, what if you update the firmware on one of it and it breaks your access, right? At least you still have a second redundant one. So to do our bad management and recovery. So I think even this redundancy and also risk averse firmware upgrade, I would say allow the system vendor to choose which NIC and what firmware it operates at makes sense. That's my opinion. I would like to hear from Whitney and Bobby and Hemo and the team as well.
Yeah, I think let me ask Bobby. So let's start with originally what John was asking, and if you can expand to like multiple.
Yeah, so for us, bear in mind that our track is very early in its thinking. We're still defining interfaces. We're not as advanced as Whitney and Damien in terms of building hardware yet. We're getting there, but I think what makes what we're doing different is two things, right? One is this notion that a multi-chiplet package is kind of halfway between a single device and a board. It has some features of a board where you have multiple devices inside it, and it has some features of a chip where it has to behave as a monolithic device in some fashion. And so one of the things we're kind of curious about is whether there's a notion of hierarchy in this management. That one of the proposals we have is to sort of create the idea of a management chiplet, which then sort of is one level in the hierarchy that the external world talks to the other chiplets through this management chiplet. Now, I'm not familiar enough with Redfish to know whether that's how heavy that management chiplet needs to be if we support Redfish, what how information gets passed through, the degree to which the insides of the packaged multi-chiplet device are exposed to the outside. So trying to figure out how hierarchy plays in is, in my mind, sort of the big challenge in figuring out how to use something like Redfish. One of the big things we have now going is the group has built a multi-vendor POC, proof of concept, where we have a POC where we have 3 different daughter cards, which are kind of like chiplets from different vendors. And we'd like to try out in actual implementation this idea of standards-based management on the POC to see how it would work out when we're managing devices. If we appoint one of those 3 pitchlets to be the management pitchlet and we tell it to go and update the other 2, how would this work out? So we have lots of questions, very few answers where we are right now is the easy way to put it.
Well, it sounds like then I should 10-year project meetings at least once.
Yeah, I think, and I was going to step back, John. This was great and discussion was good. To me, maybe from between hardware management and all this sub project, and this is why we have this panel. Like if you look across firmware update, monitoring, inventory, there are some common use cases across all those 3, as Bobby, Whitney, and Damien highlighted. What we can do is we can have that from hardware management project Redfish model, as well as incorporate this internal facing interfaces, as Damien was talking about sideband. That'll show like full end-to-end path of how from Redfish model things eventually can get to these devices using standard interfaces. And maybe we should have a separate session between the sub projects and hardware management project to start discussing those. This is a great discussion here.
Well, to answer Bobby's immediate question, so the Redfish model actually has 3 main model resources. One is the chassis, which is sheet metal containment structure, a computer system, which is the logical compute unit, and then the third is the managers, and all 3 of them can be created into hierarchies. So the chassis can be created into hierarchies from blades to to sleds to racks, so on and so forth. The management can also be structured in a hierarchy where managers can manage other managers. So when you talk about chiplets, which have management units on them or functionality on them, then you could look at a BMC being a manager of the sled, talking to 3 separate managers, each within a chiplet. And that would be actually easily modeled within Redfish. So, I think a discussion would be good.
There's also some other, yeah,
sorry.
if I could interject real quick. There's also a session that you missed because of OCP profiles for platform manageability being at the same time. It was called Composable Independent Firmware and Control Plane. And they show how you can do some of this, including large images with, you know, a new or rather modified management interfaces other than NCSI or I2C, which I agree is way too slow. But they're using RDE to do all the Redfish model over MCTP, so you don't have to do it straight in JSON mode. So yeah, there's some things that could be done here, and there's other groups doing it as well. So I think a cross-group effort would make sense.
Yep, I think that's what I'm taking out of it. So
I do have one follow-up for John, if it's okay.
Yeah, go ahead.
So I think the big thing we're you know debating more from a position of limited knowledge than anything else is that if you're going to compose multiple chiplets into a package, are you better off saying each chiplet should be managed from the BMC as an independent device inside the package? Or are you better off saying there is a single chiplet called the package manager, which acts as a middleman between the BMC and the chiplets in the package? Is one preferred over the other, or do we allow both? Or I think that's one thing we're sort of looking to the management track for some sort of guidance, as it were.
Okay, so I will give you the DMTF Redfish answer first, which is that's irrelevant, and that's an implementation issue. And the job of Redfish is to model both of them. That whether you have them all in the BMC or whether you have them spread across the chiplet, Redfish should be able to manage both types of instances or constructs. So to answer your direct question, which is what is guidance, I think that I would lean on the OCP hardware management group based on their experience on whether, you know, it is better to manage things centrally or distributively.
I'm happy to hear that we're going to support both, and then because for the OEM side, right, we actually see both implementation. Some of the OEM, because of the number of like sensors and then whatever the data we need to have collect from the module, and then the module itself, when they design the OEM, right, besides the chip itself, they have actually a microcontroller like in that module, and then collect this information and filter out and then communicate with the BMC on the baseboard. So this is one case, and then there are also cases BMC gonna talk to the accelerator chip directly. So we, like in the OEM field, we already see both implementation.
Yeah, I think one other thing I was going to add to that is later in the day today, we have this session on chiplet management, Bapi and I have, where some of these thoughts, what we are talking about, you know, a couple of slides on that. So this is great discussion.
Let me question for John.
Yeah, go ahead.
Or Hamel. So I've been listening to this conversation about, you know, management of accelerators and devices and chiplets and modules. Does this lead us to a path where we have a profile for a particular function, a new profile for a ODSA device, a chiplet, or an OEM device, and then how that profile is implemented is, like you say, John, is implementation specific, but at least we capture the redfish profiles that should be supported.
So
go ahead, John.
I think to date, we've talked about this baseline, and then we've talked about platform level profiles that extend from the baseline. And what we're talking in this is something different. This is component-focused profiles, right, for an accelerator. And those just become fragments into a greater platform profile. So we haven't talked about this concept of profiles, which are not profiles getting bigger and bigger as the platform gets bigger and bigger. This is specific fragments within the profile. Like when I was doing the baseline, I want to add firmware update immediately, right? But most people couldn't support that. So we could have a firmware update profile, which talks about functionality within an OCP platform, and say, if you want to do firmware update, you shall conform to this profile. And it's kind of a sub profile, right? Because it's not a big system. It's just a profile focused on a particular capability, management capability on a platform.
So
yeah, I think there is sub profiles, and I can see how there would be certain management requirements built into these modules that you'd want to make available to an orchestrator, or make available out of band through telemetry. I heard a similar study this morning in the HPC track where they were using additional telemetry information to manage the HPC deployment.
yeah, and Bill, to add to what John was saying, maybe not firmware update profile, but John and Bill, we can also think about a component level profile, like sub profile, device profile, because I'm hearing here between this panel is great. That way we are hearing some common use cases around the monitoring inventory, firmware update. And also there is one other part, hardware management project we have not yet tackled, but across all these devices, the internal interfaces that they want to use. So this way you have a profile through which you are externally getting to the platform to get this device management. But then within the platform, you have a common set of mechanism through which you can define and taking firmware update, for example, redfish model, and internally using PLDM to transfer firmware images, right? So this gives you a solution from all the way management client to the device, which is based on standards. So I think we need to discuss this within hardware management project in more details, as well as talk with all the sub projects.
Yeah, I can see how there could be a need for the hardware management team to define, how these sub properties are defined and managed, because we have tremendous expertise today in these sub projects, and I look at like Whitney's group or Boppy's group, they're going to bring out very specific telemetry information that they want to expose, or unique management functions that they want to enable. And I think that it'd be great if we can capture that, the input from those subject matter experts. And I think from the hardware management perspective, be able to define how these modules are put together into a system.
Yep. Point. And this is the beginning. That's why we are kicking off here in panel, but this should morph into that effort. Let me ask Dirk.
I was going to say, one of the things we're interested in, I think that'll be interesting to our group, is this idea of a profile in reverse. Like, at least for the ODSA, we're defining a physical interface. Say this is the physical interface where chiplets communicate. Then we're defining a logical interface. This is how data transaction protocols go. A profile may be a mechanism to define a management interface, which kind of says your profile needs to support firmware updates, it needs to support telemetry of these parameters. And if you can define that, and then that becomes a part of the sort of ODSA interface stack, that would be a nice little feature to have. To turn it in reverse. Kind of say, this is the price for admission. You need to have a profile with these attributes in order to be compliant, as it were.
Yep, I think great comment. Let me ask, we have only a few minutes left here. Dirk, do we have any questions from the audience in addition to what we're discussing here on
We
the.
do not have any new questions yet in the chat or in the Etherpad. So I would suggest just keep talking. Our next session is up in 6 minutes.
Okay, so I do have one question for all three panelists that I want to ask. So as you know, security is becoming more and more important, and within platform security now people are looking at different attack surfaces. So my question to all three of you is, from your standpoint for the management within like MES group or OAI or ODSA, what do you see are the security related use cases and challenges? And maybe let me start with you, Damien.
Yeah, so for today, yeah, security definitely is important. And as I mentioned earlier, that in even our next 3 years old, we recommend secure boot. There are one new area, I think relatively new, data management protocol that was introduced first in USB-C and then later on port to MCTP. It's like the security protocol and data management, SPDM. I got a download from one of my system software engineer expert, Ben Wei, on this area. And we have a chat, and we think that this is important that for the NIC to support, because at this time, the NIC spec primary and fastest hardware management interface is still NCSI or MRI. So porting over this protocol support onto NCSI in our thought is important, and this is a gap in today's NCSI 1.2 definition, which doesn't have. So this is an area that I hope that we can close together with hardware management on this area.
Okay. Yes, I think that gap is known, and at least in DMTF, SPDM has been, as you see, the MCTP binding is published, and SPDM continues to work on future.
Okay, when the gap is known, so is there some timeline that you think that this could be supported? What's the phase of this porting?
I think, as you know, SPDM 1.1 and the MCTP binding, they are published, right? So now we understand. I cannot specifically comment on specific timeline, I think, but it's been considered to be one of the gap, and it's being addressed. Okay. Damien, thanks for. Let me ask Bobby your view on security.
Security is basically related to our number one, what makes the ODSA unique, right? Heterogeneity. So if you're mixing chips from multiple vendors, chiplets from multiple vendors, you want to know that you're talking to an authentic chiplet on the other side. When you bring up your die-to-die PHY, you almost want to know that you're talking to the real deal on the other side. So we essentially have, we sort of decided to take a punt on it in for version 1 of the PHY, but we looked seriously at saying, is there any way for the die-to-die PHY that connects the chiplets to verify that you're talking to an authentic chiplet? So right from the PHY all the way up to the software, everything we have, I think it's a important issue to address, which is not there yet.
Okay, thanks. Whitney? I know we are running out. Go ahead.
Yeah, from my side, I think in the latest, for example, OEM spec, right, we also defined the security related requirements, like what Damien mentioned, MCTP over DMTF, such thing. The concern or the challenge for us is really for accelerator case, right? We normally have a multiple accelerator in the same system. So it adds to the I2C like a communication really heavy. And then addition to these security requirement and protocol need to support, it actually further slow down since we have an extra communication, right, for that. And then it just the speed, right? That's the major challenge. And then I want to see, like, when we define these management requirements, right? I think the protocol, the interface also it's something we can discuss and see whether we can push maybe next generation and higher speed.
Okay, sounds good. Thanks, Whitney. So in the interest of time, let me close the panel. Let me first thank Whitney from OAI, Bapi from ODSA, and Damien representing Maz and Nick sub-project. This was great discussion, great panel. As we discussed during that, we want you to contribute to this standards activity as well as closing the gaps we just talked about. And you can find links to hardware management project as well as other sub-project representation we had in here. So with that, let me conclude. Thanks everyone on the panel as well as thank audience. Bob, back to you.
Thank you.
All right, thank you, Hemo,
Thanks.
and everybody in the panel. It was a very good discussion. Our next topic is to run BMC, a BMC standards interface. So the presenter is Eric from Dropbox. And Eric, if you're on, please take it away.
Eric, you're on mute.
Hi, everybody.
We can hear you.
Hello.
Okay, sorry, I had some difficulties, but I think I'm good to go. This is Eric Schob. I think I'm up next. Should I present